Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, a convex hexagon, that means that we have 6 sides, has exterior angles with measures 34, 49, 58, 67, and 75. What is the measure of an exterior angle at the 6th vertex? Okay, so personally, I like to draw a picture, get a feel for what's happening here. So, a hexagon means that I have 6 sides, so something like that. Now this looks like, close to a regular hexagon. It's not. I just wanted a 6-sided shape, and this is how I know how to draw a 6-sided shape. Now I'm going to extend each of these, only one. I'm going to extend going counterclockwise. Okay, so our exterior angles are these angles right here. And we know that one of them is 34 degrees, one is 49 degrees, one is 58 degrees, one is 67 degrees, one is 75 degrees, and we don't know what the 6th one is. That's what we're trying to find, is the measure of an exterior angle at the 6th vertex. Now, of course, this is not drawn to scale. The 34-degree angle looks basically the same as the 67-degree angle. I know I didn't draw this very well, but it lets us see what's happening. It's not perfect, but it lets us see what's happening. So, I know that each of these exterior angles should add up to 360 degrees. That's what the polygon exterior angle theorem tells me, is that all the measures, the sum of the measures of all the exterior angles equals 360 degrees. No matter what, no matter how many sides we have in this shape. So, that means that 34 plus 49 plus 58 plus 67 plus 75 plus x should be 360 degrees. So, let's combine our like terms. 34 plus 49 plus 58 plus 67 plus 75 is equal to 283 plus x equals 360 minus 283 from both sides, and x is equal to 77. So the measure of this angle is 77 degrees. And there we go. Alrighty, let's move on to what we have for today. Today we're moving on to section 7.2. 7.2 is about properties of parallelograms. Parallelograms are very interesting shapes, and they give us more shapes that we'll talk about in 7.4. So, today we are asking, what are the properties of parallelograms? What makes a shape a parallelogram? And what, if I have a parallelogram, then what do I know about this shape? So, our learning target is that we know the properties of parallelograms. We know what they are. And our success criteria is that we can use these properties of parallelograms to solve problems. So I know the properties and I can use them to solve problems. Let's go ahead and start with, what is a parallelogram? How are we going to talk about the properties of a parallelogram if we don't know what a parallelogram is? So, in the word parallelogram, you see the word parallel. So, a parallelogram is a quadrilateral, so it has to have 4 sides, must have 4 sides, with both pairs of opposite sides parallel. So, the sides that are opposite are parallel. Top and bottom, parallel. Left and right, parallel. Opposite sides are parallel. Now, if only one of the sides is parallel, or only one pair of opposite sides are parallel, we don't know that that's a parallelogram. We need both pairs of opposite sides to be parallel in order to know that we have a parallelogram. So you better see all of these red marks. You better see one arrow on opposite sides and then 2 arrows on the other opposite sides in order for this to be a parallelogram. All the sides must be parallel. And you'll remember from chapter 3 that these red arrows mean parallel. The ones that have one red arrow match, they go together, they are parallel, and the ones with 2 red arrows match, go together, they're parallel. So the side that has one arrow is not parallel to the side that has 2 arrows. That's why there's a different number of arrows. The ones with 1 arrow go together, and the ones with 2 arrows go together. Alrighty, that's what a parallelogram is. Now let's learn some theorems about parallelograms. Let's learn some properties about parallelograms. If a quadrilateral is a parallelogram, if I have a parallelogram, then opposite sides are congruent. So if I know that this is a parallelogram, that means that they tell me it's a parallelogram or I see these arrows. If this shape is a parallelogram, then the sides that are parallel are also congruent. So the opposite sides are congruent. Top and bottom, congruent. Left and right, congruent. Again, remember, if these have 2 tick marks, they match. If they have 1 tick mark, they match. So the sides with 2 tick marks are congruent, and the sides with 1 tick mark are congruent. But if one has 1 tick mark and one has 2 tick marks, not congruent. Not congruent. They have to match. So the opposite sides are congruent. If I have a parallelogram, opposite sides are congruent. The parallelogram opposite angles theorem. What do you think this one says? So this says if a quadrilateral is a parallelogram, so if I have a parallelogram, then its opposite angles are congruent. So the angles across from each other are congruent. So Q and S are congruent, and E and R are congruent. Again, notice 1 tick mark matches with 1 tick mark. 2 tick marks match with 2 tick marks. So that tells us that Q and P are not congruent because this one only has 1 tick mark and this one has 2. Okay, so if I have a parallelogram, the opposite sides are congruent and the opposite angles are congruent. Nice. Very interesting. Also, you can prove these theorems using congruent triangles from chapter 5. Give it a try if you're interested. Okay, so let's use these properties to do our first example. So our first example asks us to find the values of x and y. Now, notice that I have these red arrows here. This is important. This tells me that I have a parallelogram. They could say, you know, AB shape, quadrilateral, ABCD is a parallelogram. They could say that, or they can give us these red arrows. Both of those things tell us, hey, this is a parallelogram. And it's important that we know that this is a parallelogram because I can't use the properties of parallelograms unless I'm working with a parallelogram. So, find the values of x and y. Well, let's see. X plus 4 is this side AB right here. Well, hey, in a parallelogram, opposite sides are congruent. So that means that if this side, if CD is 12, AB needs to be 12. So I know that x plus 4 has to be equal to 12. What does that make x? Minus 4 from both sides. X is 8. Boom. Done. Opposite sides are congruent. All right, that's x. Now let's take a look at y. Y is angle A. And hey, in a parallelogram, opposite angles are congruent. So the angle that is opposite angle A, which is angle C, is 65. So y must be equal to 65 degrees. There we go. Huh. Let's check and make sure that we were correct. Opposite sides of a parallelogram are congruent. So x plus 4 equals 12, and x is 8. Parallelogram opposite... Oh, I'm in the way. The parallelogram opposite angles theorem says that angle A is congruent to angle C. Measure of angle A is equal to the measure of angle C. So y equals 65. And x equals 8. And y is 65. Aha! Aha! We were correct. Okay. Let's move on to a couple more theorems, a few more properties of parallelograms. So, we have the parallelogram consecutive angles theorem. So before we looked at the opposite angles theorem, now we're looking at the consecutive angles theorem. So consecutive, remember, means one right after the other. So consecutive is angles that are next to each other. We'll say next to each other. All right. If a quadrilateral is a parallelogram, if I have a parallelogram, then consecutive angles are supplementary. So notice, let's look at this diagram for a second. They have that angle Q is x degrees and angle S is x degrees. We know that because of the opposite angles theorem. So the angles opposite each other better be the same. So that's why they have x, y, x, y. That's why they have that pattern. So if I take x and y, that needs to be equal to 180 degrees. So the angles that are next to each other, whether it's Q and P, whether it's P and S, whether it's R and S, or whether it's Q and R, whatever it is, the angles next to each other are equal to 100, or add up to 180 degrees. They are supplementary. Okay, and the next theorem is the parallelogram diagonals theorem. We learned about diagonals in section 7.1. That's when you connect two non-consecutive vertices. So, basically drawing an X across the shape, connecting the opposite sides. In a quadrilateral, you're connecting the opposite angles. Okay, so if a quadrilateral is a parallelogram, if I have a parallelogram, then its diagonals bisect each other. What did it mean to bisect something? Oh, I'm writing behind my head. Bisect meant to cut in half. So, where the diagonals cross, they cut each other in half. So if PM is 5, that means that RM is 5. They cut each other in half. If QS is 3, that must mean that RS is 3. Whatever we have on one side of where the diagonals cross, whatever that is, it is the same on the other side. So if it's 12, PM is 12, RM is 12. Okay, awesome. Let's take a look, a little bit deeper of a look at these theorems. So, understanding the parallelogram consecutive angles theorem. Stop moving. So, the consecutive interior angles theorem, remember from chapter 3? Remember when we were talking about transversals and parallel lines? Well, we said that consecutive interior angles were supplementary, that they added up to 180 degrees. This parallelogram consecutive angles theorem is basically the same thing, because when I have a parallelogram, I'm talking about both sets of opposite sides are parallel. So I know that my top sides are parallel, and I know that my sides, I know that the top and bottom and the left and right are parallel to each other, respectively. So that must mean that, yeah, consecutive angles are supplementary, just like the consecutive interior angles theorem from chapter 3. So if that helps you kind of remember this, great. Also, the parallelogram diagonals theorem, all of these theorems can be proved using congruent triangles from chapter 5. So if you want more of a challenge, try that. See if you can prove any of these things using the congruent triangles from chapter 5. So that's a little bit of background info behind the parallelogram consecutive angles theorem. Now let's use this theorem in another example. So, as shown, part of the extending arm of a desk lamp is a parallelogram. So that's the red shape they're talking about here. That is a parallelogram. The angles of the parallelogram change as the lamp is raised and lowered. Makes sense. So they want us to find the measure of angle BCD. So BCD is this corner. They want us to find the angle measure of this corner when ADC, okay, when this corner is 110 degrees. Okay, I don't know about you, but this shape is too teeny for me to work with, so I'm going to redraw that. I'm going to draw it a little bit bigger. Okay, and I have A, B, C, and D. This is not perfectly to scale, right? Obviously, AD and BC are much shorter relative to AB and DC, but that's okay. Doesn't matter for the purposes that we're working with. We know that the measure of angle ADC is 110, and we would like to find what is the measure of angle BCD. We would like to find the measure of this angle. Well, remember that we are told that this part of this extending arm is a parallelogram. So we can draw some red arrows on here. And, hey, we know that consecutive angles in parallelograms are supplementary. So, 110 and whatever measure of angle BCD is must equal 180 degrees. If you don't like using question mark, we can use X. Doesn't matter. Doesn't matter at all. It's whatever your heart desires. Whatever is easiest for you to understand. So if I subtract 110 from 180, I get 70 degrees. So the measure of angle BCD is 70 degrees because of the parallelogram consecutive angles theorem. Let's check and see if we were correct. All right, by the parallelogram consecutive angles theorem, they are supplementary, so they add up to 180. 1 is 110. 180 minus 110 is 70. Ta-da! Awesome. That's what we did. So, that is all I have for you in this video. Now is the time to rate your understanding of the learning target and the success criteria. How are you feeling about, How are you feeling about parallelograms and properties of parallelograms? Are you still a little confused about what the heck a parallelogram is? Are you like totally lost? Do you think, okay, all right, parallelograms, parallel sides, okay, opposite, things, you kind of, get it, but you're not feeling super confident? Or are you like, oh yeah, everything makes perfect sense? Wherever you are on this spectrum, take the appropriate action. Ask questions, try the homework, help your friends, classmates, family. Do what you need to do to make sure that you understand the learning target and the success criteria. Do you know the properties of parallelograms, and can you use these properties of parallelograms to solve problems? So, here are some practice problems. There are some on the slide right here. There are some on the next slide as well. These problems will help you practice the skills that you have learned in this video. They'll help you solidify your rating of yourself. Like when you said, oh, I think I'm a 3 out of 3. I think I'm a 3 in understanding the learning target and the success criteria. Well, if you can't do half of these, maybe you have a few more questions than you thought you did. So try these practice problems if you'd like. Of course, do the homework that your teacher assigns as well. And let's end our video with a launch, just like usual. So today's launch comes from Frank A. Clark, and he says, if a person isn't thankful for what he's got, he isn't likely to be thankful for what he's going to get. Ooh, this is good. If somebody isn't thankful for what they have, they probably aren't going to be thankful for what they get. So, have you ever thought like, oh man, if only I had, a new iPhone, then I would be happy? Or, oh man, if only I had all A's, then life would be great. If only this, then everything's fine. Then I can be content. Well, if you can't be thankful for what you have right now, it probably doesn't matter what you get. You're always going to want something more, right? Once the newer version of the iPhone comes out, then you have to have the newer version. Once you have all A's, then, I don't know, then you need something more. Then something else. It'll be something else that you want. So, and it's not always true, right? It's not always true. Maybe sometimes you get what you want and then you are satisfied. But he says it isn't likely. The probability is not very high. The chances aren't good. It is unlikely that if you're unthankful or you're not thankful for what you have right now, you're probably not going to be thankful no matter what you get. So if you can change your attitude, to, hey, I am thankful for what I have right now, even though I would like something else, even though I would like a new iPhone or a new whatever, I can be happy with what I have. The phone I have right now works. And it works pretty well. I like the camera. If you can be thankful for what you have now, you can be thankful no matter what. If you're not thankful right now, can you be thankful no matter what? Hard to say. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.